All right, let me get on the right page here. Going from one lesson to the next as I record these. Once again, still trying to get these done before my husband leaves. All right. Ooh, how did we flip there? Let me go back to this. It doesn't want to do it. Oh, there we go. Rotate. Again. There we go. There we go. All right. Did I make you dizzy? All right. So if when we're multiplying by tens, hundreds, and thousands, we're making our number bigger. We're adding zeros that way. We're moving the decimals that way. Dividing would be the exact opposite. Everything's going this way. And we're making our numbers smaller. All right. So if you think about that, it'll make sense as you do it. All right, so go right down into the problems. If we look at the first one, they've done it for us. We're dividing each number by 10, 100, and 1,000 respectively. You know what that word means? That means in order, okay? Nice big word that they stick in there that helps us. You do it respectively. You do it from smallest to largest, or the most logical order. All right. So if we have 9,276, the decimal is right here. So if we divide by 10, we move the decimal there. And you see down here they have it. If you multiply by 100, you move it over twice. If you divide, am I saying multiply? If you divide by 1,000, the decimal comes here. So here's the decimal divided by 10, divided by 100, divided by 1,000. Easy? Let's try it. So in 478, here's our decimal, right? If we divide by 10, it would now be between the 7 and the 8. Divided by 100, it's now between the 4 and the 7. Divide by 1,000, and it's at the very beginning. See how we've made the number smaller and smaller. 324 divided by 10 becomes 32.4, then 3.24, then 0.324. So divide by 10, move the decimal over once. Divide by 100, move the decimal over twice. And we're basing it on how many zeros. Divide by 1,000, 1,000 has 3 zeros, move it over 3 places. 6,072 becomes 607.2, and 60.72, and 6.072. 23,941 becomes 2,394.1. We'll still put a comma in there. And then it becomes 239.41. That's not a point there. That's just where I messed up. There. And then 23.941. All right. Divide each decimal by 10, 100, and 1,000 respectively. Annex zeros or add zeros to the left of the number. Before it was to the right. Now it will be to the left if necessary. So look at the 0.3 first. Look how they did it. So 0.3, if we divide by 0, we have to actually move this decimal over here one place. So now it's 0.03. Divide by 100, you have to move the 0 over twice. So you have 2 empty spots. Put zeros in them. Divide by 1,000, you move it over 3 places. You have 3 empty spots. So you put the zeros in there. Okay, those zeros are very important. All right, so remember, just as a reminder, because sometimes people forget, if that's my number 0.9, if I put a 0 over here, I have not changed the value at all, okay, because 9 in the tenths place is the same as 90 in the hundredths place. If I had another 0, that's the same as 900 in the thousandths place. And why? Because these all reduce to 9/10. Do you see that? On the other hand, 0.09 is not the same as 0.9. That is 9 in the hundredths place, and that is totally different than 9 in the hundredths. That's like 9 out of 100, whereas this is 9 out of 10. If I have 0.009, okay, that's 9 out of 1,000, which is not the same as 9 out of 10. Same way, it's like the opposite in whole numbers. Now we're not erasing. Not going to work. I don't want to erase everything. In whole numbers, if I write a 9, okay, if I put a 0 here on the other side, and I don't have room, let me try the 9 over here. If I put a 0 there, that's still 9, right? It's still 9 in the ones place. I could put a 0 here, it's still 9 in the ones place. Do you see that? So in the whole numbers, it's the opposite direction. You put zeros over here, it doesn't change anything. But if I put zeros over here, this is 9. That's 90. Totally different. These are different numbers. So the zeros on this side in the whole numbers, they matter. Whereas in the decimals, they don't matter. It's kind of crazy. It's the opposite. So don't forget that. All right. Where were we? So 0.9, if I divide by 10, I have to move the decimal to the left one place. So that leaves me a spot to put a 0. What I'm doing is if I have 0.9, I'm moving the decimal to the left one spot. And then I have this empty spot right here where I put in a 0. If I divide by 100, I have to move it over 2 places. And so now I have a spot for 2 zeros. If I divide by 1,000, I move it over 3 places. So I have a spot for 3 zeros. If I have 2.4 and I move the decimal over 1 place to the left to divide by 10, now I have 0.24. I hope this is making sense. The division's a little bit more difficult for some reason. All right, if I divide by 100, you got to move that decimal over 1 more place, which will give me an empty spot for that 0. Divide by 1,000, I have to move it over 1 more, and that leaves me a spot for 2 zeros. 57.8. If I move it over 1 place to divide by 10, this is divided by 10, that would become 5.78. If I divide by 100, it becomes 0.578. Now at this point, I'm all the way to the left, so if I divide by 1,000 now, I have to move it at 1 more place, and that'll leave me a 0. Whoops. So look up at the 57.8. If I said right off the bat, divide that by 1,000, you would say in your head, well, 1,000 has 3 zeros, right? So I have to move this to the left because I'm making it smaller, 3 places. So I make these 3, let me do it out to the side. So you have 57.8, right? And I say, class, divide that by 1,000. So in your head, you think 3 zeros and 1,000. Move the decimal to the left because we're making our number smaller. And I make 3 little jumps because I'm dividing by 3 zeros or by 1,000. And then I can see that I have an extra space there. See how that works if you do it right away? Let's try that with the 0.4. So if I have 0.4, I don't have much room over here, although it looks like I have room. Let's do it right away by 1,000, just for once. So 1,000 has 3 zeros. So I have to divide that by 1,000 3 times. Do you see that? So I made 3 jumps because my decimal was already to the left of my number. Add those 3 zeros in. So it's 0.0004. See how that works? All right, so if I'm doing 0.4 divided by 10, I just have to move it over once. Divided by 100, I move it over twice. All right, this is from yesterday. Now we're going to go back to multiplying each number by 10, 100, and 1,000 respectively. Okay? All right, here we go. And hey, just for something new, let's do it the opposite direction. Okay, so let's start with 1,000. 72, I'm going to add 3 zeros. Times 100, I add 2 zeros. Times 10 and 1 zero. You didn't have to, but remember, multiplying, we make our number bigger. You see how they're bigger than 72? 4.32. Let's multiply by 1,000 right off the bat. So you're going to move it over 3 places. See that? So it's 4,320. If you moved it over 2 places for the 100, it would be 432. Moved it over 1 place for the 10, 42.2, 43.2. All right, so let's do 0.68 times 1,000. So we're going to move it over 3 places. And that leaves me 1 spot for a 0. 2 places for 100, 1 place for 10. 9, let's multiply it by 1,000. Well, that's easy because you already know 9 times 1,000 is 9,000, right? And what you've done is you've moved that decimal over 3 times. All right, 0.052. What would that be multiplied by 1,000? Move it over 3 places. And don't write that 0 because now it's a whole number and you don't need that 0 in front of it. What is it times 100? We'll move that decimal over 2 places. Did you get 5.2? Move it over 1 place, you have 0.52. And you don't need the 0 over here. It's not necessary. All right, solve these story problems. I'm curious how far I can write down. Not very far. That's about as low as I can write. Okay. Miss Marsh bought 10 tickets to the concert. Each ticket cost $2.50. Now this is where it's real practical. So what's the cost of her tickets? So if you're buying times 10, $2.50, you just have to move the decimal over 1 place. So $2.50 becomes $25. Or you could write it with the 2 zeros there if you want. Miss Roper bought a box of 100 writing notes that cost $5.95. What was the cost per note? So we're taking the whole box and we're dividing it up into per note card. So we're dividing it up. We want to know how much each one costs, and they want us to round it to the nearest cent. So if it's 5.95, don't worry about the dollar sign yet. We're going to divide that by 100. So you move it over 2 places. You get 0.0595. But since this is money, they want you to round it to the nearest cent. And remember, 2 places after the decimal is all we have in money. So if it's 0.0595, we look at that 9 and ask, what will that do to that 5? And obviously it'll round it up. So it's 0.06 or 6 cents that each one costs. Pretty close. See how that worked? Let me try that. I'm going to do that one more time just because I don't have you in front of me to somebody say, I don't get it. So you have a box that has 100 cards in it, okay? And you paid $5.95 for the whole box. They want to know, how much does each card cost? Well, 100's a nice even number where we can do that moving the decimals over, right? So we can do 5.95 divided by 100, which means we're moving the decimal this way because we now know that. And I get 0.0595. Do you see that? All right, this is money, and I can't give you 0.590595 change. I could only give you up to 2 places, all right? So I look at the 9, and that rounds that 5 up to a 6. So I can say that each card cost about 6 cents, or you could write 6 cents. Okay? All right, let's go to the back. All right. Change these to decimals and round off to the nearest place tenth if it's not exact. All right, can I write up here? No, but I can write there. I can write down here and erase it. All right, so 2/3. 2/3 we should have memorized, so we're not going to divide it. All right, 2/3. 1/3 is 0.3 repeating. 2/3 is 0.6 repeating. So it's 0.6 repeating, right? So something like that. But they want me to round it to the nearest tenths place, the first 6. So the next 6 will tell me to round that 6 up to 0.7. 3/8. I think we memorized 3/8. Not all of these have we memorized, but 3/8 would be 375. So 0.375 ends. It does not repeat. So it says round off to the nearest 10 place if not exact. This one does end. So we'll just write 0.375. 2/5 ends also. Remember what that was? 0.4. 2/9. Well, let's see what 2/9 is. We didn't have to memorize that. So it's 2 divided by 9. Add a decimal. 9 into 20 would be 2 times. Oh, this doesn't. This is going to be, looks to me like this is a repeater, isn't it? This would go on for all of eternity. So what will that round to? 0.2. I should have known it was a repeater because 3s are repeaters, 6s are repeaters. If I was thinking patterns, then 9 should be repeaters also. And I'm guessing, would 11s be? Maybe? No, 3, 6, 9. Well, I don't think it would be. I don't know. All right. 1/6, we memorized that. I can't remember it, so I'm going to divide it. So it's 1 divided by 6. 6 goes into 10 once. You probably remember it, but I don't, so I'll divide it. That's 6 goes into 46 times. 6 goes, we got that repeating 6. So it's 0.16 repeating. Now I remember it. So since it's repeating, they want us to round it to the nearest tenth. So that 6 will take that 1 and make it a 2. All right, perimeters and area. Don't forget there's both here. Down here, all of those look pretty easy. Change fractions to lowest terms. So what you're going to do, first of all, put it over whatever place it was. 425 would be 425 thousandths. And then you're going to reduce that. All right. How do we know? Well, like for instance, with 4 yards and 3.1 4 feet and 3.1 yards, let's change this one to feet. Okay, yards to feet is multiply.
She's not able to get to the dentist at all.
and 3 yards times 3 feet would be 9 feet, plus one more would be 10 feet. So 3.1 yards is the same as 10 feet. Which one's bigger? Okay. This one, change that to an improper fraction. Solve this one, and this one you can figure out. All right. On these, they all divide out evenly, so you shouldn't have any problem with that. All right, I think we're done. I'll leave you to yourself to finish the rest of this. Have a good day, and I'll see you tomorrow.